Now, students, in Chapter 2, which is the chapter we are starting today, we will be looking at polynomial functions and rational functions, okay? That's what we'll be looking at throughout Chapter 2. For now, we will keep our focus on polynomial functions. We will get to rational functions toward the end of the chapter, okay? In this video, we will be looking at a very familiar topic called quadratic functions. Now, I'm going to go pretty fast in today's notes because it's really material that was already covered back in Algebra 1 and Algebra 2, but it's still good to quickly go over it, review it, before we jump into a lot more difficult polynomial functions. Your heading today is called Quadratic Functions, Lesson 2.1, and be sure and include today's date. Quadratic Functions, Lesson 2.1, and be sure and include today's date so that your notes are organized. First, let's review what a quadratic function is, okay? Now, simply put, it is a polynomial function that has a degree of 2. For example, in case you've forgotten what degree is, it's the highest exponent of your variables. So, if I have a polynomial function written like this, this would be a fifth degree polynomial function. Fifth degree polynomial function, because the highest exponent of your variables, and by the way, the exponents of your variables are 2, 5, and 3. The highest one is a 5, so we would say the degree of your polynomial function is 5. It's a fifth degree polynomial function. So when we're talking about quadratic functions, simply put, it is a polynomial function. A quadratic function is a polynomial function that has a degree of 2. Okay? It has a degree of 2. So this would be an example of a polynomial function. This would be an example of a polynomial function. Okay? And there are others I could give you also. It can come in many forms, so please make a note of these different forms of a quadratic function, okay? I would encourage you to write all of these down. Okay, number 1, here's an example of a quadratic function written in general form. Now let me be very clear. You do not need to write down general form. Maybe later you will. Maybe later you will in this chapter, but not right now. I'm just telling you, this is a quadratic function written in general form. Now, how do I know it's a quadratic function? Because the degree is 2. The exponent of the x here is 2. The exponent of the x here is 1. What's the highest exponent? And by the way, if this 3 had an exponent of 4, it wouldn't matter. I'm talking about variable exponents, or in other words, the exponents of the letters. Okay? So the exponent of the letters would be 2 and 1. What's the highest one? 2. So this is a quadratic function. Okay? Quadratic function. Here's another example of a quadratic function. Okay, now I'm going to show you in a second how we know this is a quadratic function, okay? But go ahead and copy this in your notes. This is called standard form, by the way. Standard form. We're going to talk about that a little later during the lesson today, okay? Standard form. Now, students, how do I know that this is a quadratic function? Well, let me show you. See, this is x plus 1 to the second power. If I take x plus 1 to the second power and simplify it, see this 2 right here. Put a 2 right here. You can take notes on this if you want to. You don't necessarily have to. I'm just trying to show you how I know this is a quadratic function. Okay, first of all, x plus 1 times x plus 1 would be x squared plus 2x plus 1. And then take your 2 and multiply it through. 2x squared plus 4x plus 2 minus 3. 2x squared plus 4x minus 1. So when I simplify this entire right side, it equals this. And this is obviously a quadratic function because the highest power is 2. Thus, it is a second degree polynomial function. Now, I would learn to memorize this model right here if I were you, okay? I would learn to memorize this. Anytime you have a parenthesis squared and inside it you have x and a number, that is going to give you a quadratic function, okay? Alright, so keep that in mind. Alright, number 3. This is a quadratic function, obviously. You do not have to have an x term and a constant term to have a quadratic function. All that you have to have is a degree of 2. And this is a degree of 2. So that would be a quadratic function. This would be a quadratic function right here. Again, you don't have to have an x term and a constant term. You can have just a constant term as long as your polynomial function is a degree of 2. And this is, okay? And then lastly, if I'm going too fast, just pause the video. Lastly, that would be a quadratic function. How do I know that? Well, because you have two sets of parentheses, and the degree or the power of each of your variables is 1. Anytime it's like that, anytime you have a first degree polynomial in a parentheses times a first degree or a linear polynomial in a second parentheses, when you multiply that out, you'll get a quadratic. In fact, if you were to multiply this parentheses times this parentheses, you would get 3x squared minus 12 over here, positive 4, negative 9, negative 5x. Okay? So there we go. So these are all good examples of quadratic functions, and the main thing you need to remember is a quadratic function, simply put, is a polynomial function that has a degree of 2. Okay? It has a degree of 2. Now, let's quickly review what the graph of a quadratic function looks like. Okay? Remember, when you graph a quadratic function, students, you should remember this from Algebra 2. Take some really good notes, please. You're going to get a parabola. Please make note of that, a parabola. And it's either going to open upward or it's going to open downward. Okay? Please take notes on this. Well, that's a really good parabola, isn't it? Let's change that a little bit. Now, remember this point right in the middle that divides the parabola right in half is called the vertex. You need to know that. And don't forget also, you can draw a line. You can draw an imaginary dotted line right through the vertex, and we call that the axis of symmetry. Now, I know this is covered in Algebra 2, so this should not be that new, okay? Axis of symmetry. You can do the same thing here if you wanted to. Draw an imaginary line right through there, and we call that the axis of symmetry, okay? And by the way, remember in the past how we learned about maximum and minimum points of graphs? Well, your vertex on a parabola is always, let me say that again, your vertex is always going to be either a max or a min, always. So in this graph here, your vertex would be a minimum point. Over here in this parabola, your vertex would be a maximum point. So your vertex is always going to be either the lowest point on the graph or the highest point on the graph, okay? So there's a little quick review of what the graph of a quadratic function looks like. Now, when it comes to graphing a quadratic function, the best method is to find the vertex first. I mean, that makes sense, does it not? The vertex gives you either the highest or the lowest point of the graph, so that helps. And it also gives you, the vertex is right in the middle of the parabola, so the vertex gives you the highest point or the lowest point. And it also tells you whether or not, it tells you where the vertex, it tells you the middle of the parabola, because the vertex is always right in the middle of the parabola, okay? Sorry about that, I kind of zoned out for a second there. So anyways, it makes sense to always find the vertex first. Now, something I forgot to mention back here, so go back to your notes, where we were talking about the, reviewing what the graph of a quadratic function looks like, and you should remember this, guys, okay? Please write this somewhere in your notes. In the situation here, x squared if a, now a is the number in front of your x squared term, okay? So when I say ax squared, that means the number in front of your x squared term. If it's positive, then the parabola is going to open upward. If your a is negative, the parabola is going to open downward, okay? So please don't forget that a is always the coefficient of the x squared term, okay? Alright, so that's really, really helpful because you can look at an equation and for the most part know whether the graph is going to open upward or downward. Then you can find the vertex, which gives you the middle. Then you can very easily plot a couple points and sketch the parabola. Okay, alright, now let's quickly look at how to graph four different forms of quadratic functions. We will not graph them entirely in order to save time, but we're going to map out the correct table of values. Then you can plot those points later if you want to and do the actual graphing. You don't have to, it's up to you. Okay, let's start off with this right here. So I want us to graph y equals 3x squared. Now, please listen to me carefully, students. First of all, we notice it is a second degree function, thus we know we have a quadratic function. So next, we're going to use this formula right here, negative b over 2a, to help us find the vertex. That's the formula you always use to find the vertex when your equation is written in general form, okay? So here we go, negative b over 2a. Now, let's quickly review what a, b, and c are. If you need to write this down, please do so. If you don't, that's fine. In mathematics, when we're dealing with quadratic functions, a is always considered, or a is always the x squared coefficient, b is always the x coefficient, and c is the constant term. So here we go. There is no x term here, so it's okay to put 0x, okay? So, where the b is, I'm going to put 0. And where the a is 3, so I'm going to put 2 times a, 2 times 3. Well guys, 0 over 6 is 0. So what you know now is your vertex is 0, comma, blank. Let's go over this again. Anytime you want to find the vertex of a parabola, of a quadratic function, you use negative b over 2a. Once you do that and you get a number out, that's the x value. Now take that number, put it back in for x, and get out the y value. And of course, if you put 0 in here for x, 0 times 0, 0 times 3 is 0. You'll get 0. So my suggestion to you students is when you fill in your table of values, I would always put your vertex in the middle, always, just like that, and then go up a couple, and then don't go down a couple like that, okay? We're not going to graph this like I said, but I'll very quickly fill in this information for you. Put a 2 in here, you would get a 12. Put a 1 in, you get a 3. Put a negative 1 in, you get a 3. Put a negative 2 in, and you get 12, okay? So if you were to graph that, you'll get a parabola, and you can do that later. I really don't think I need to go over, at this point in the year, especially with pre-cal students, how to substitute a value in and get a value out, okay? Alright, number 2. Alright, same thing, guys. Look, we have a quadratic function written in in general form. Okay? So, I'm going to use negative b over 2a. Alright, now, b is always your x term. There is no x term. Negative 2 is your a, and positive 1 all by itself is your c. But there is no b, so we can really put plus 0x if you want to. You don't have to, but you can, alright? So, where b is, I'm going to put a 0. And where a is, I'm going to put a negative 2. Because a is negative 2. Alright, but it really doesn't matter. 0 over negative 4 is going to be 0. So my vertex is 0, comma, blank. Alright, so come back over here and put a 0 in for x. 0 times 0 is 0, times negative 2 is 0, plus 1 is 1. So there's your vertex, 0, 1. So very quickly, if I were you, I would put 0, 1 here. That would go up 1, down 1, down 1, and then quickly put these points in. So put a 2 in for x. 2 times 2 is 4, times negative 2 is negative 8, plus 1 is negative 7. Put a 1 in. 1 times 1 is 1, times negative 2 is negative 2, plus Now we'll put a negative 1 in. Now when you square a negative 1, you get a positive 1, students. Don't forget that, okay? Back here I should have said something to you. When you put negative 1 in and you square a negative 1, you get a positive 3 out, okay? Excuse me, a positive 1 out. So when I put a negative 1 in square, I get a positive 1 times negative 2 is negative 2 plus 1 is negative 1. Now I'll put a negative 2 in. A negative 2 squared is 4. 4 times negative 2 is negative 8 plus 1 is negative 7. Trust me, if you'll plot those 5 points, they will line up in a parabola form. You can do that later on your own time if you want to. Alright, once again, we have another general form quadratic function. And so here we go. I'm going to use negative b over 2a to find the vertex, okay? So this is my a, this is my b, this is my c. So negative and then 8, because 8 is my b, and then 2 times a is 2. So you're going to end up with negative 8 over positive 4, which would give you a negative 2. So now I'm going to go back and put a negative 2 in real quick here. Well, negative 2 times negative 2 is 4, times 2 is 8. Negative 2 times 8 is negative 16 plus 7. Well, 8 minus 16 plus 7 does give you a negative 1, okay? Negative 1. So I know my vertex is negative 2, comma, negative 1, okay? Alright, let's go up, and let's go down. Okay, put a 0 in for x. That should be pretty easy to do, guys, because put a 0 in for x. 0 squared is 0 times 2 is 0. 8 times 0 is 0 plus 7. So, we get 7 over here. Put a negative 1 in. Square a negative 1, that's 1. Times 2 is 2. Negative 1 here gives you negative 8. And then plus 7. Okay, so that's going to give you a positive 1. 2 minus 8 is negative 6. Plus 7 would be 1. Now let's put a negative 3 in. 3 times 3 is 9. Times 2 is 18. Put a negative 3 in here, you get negative 24. 8 times negative 3 is negative 24. Bring down your positive 7. So we get a positive 1. A positive 1. And then put a negative 4 in for x. Let's see, a negative 4 in for x. Negative 4 times negative 4 is 16. Times 2 is 32. 8 times negative 4 is a negative 32. And then plus 7. So 32 minus 32 cancels out, leaving you with 7. Okay, now my handwriting's not the best. If you can't read this, it's 7, 1, negative 1, 1, 7, 7, 1, negative 1, 1, 7. Okay, if you'll plot those 5 points, you will see they line up in a very nice parabolic shape. Alright, number 4. Now this one is written in standard form. And you're going to really, really learn to love the quadratic functions that are written in standard form. They are so easy to graph. Watch this. So neat. Now, as long as you have a parenthesis squared, okay? Did you hear that? As long as you have a parenthesis that's squared, and as long as inside the parentheses you have a linear or first degree expression, and then also there can be no number with the x here, okay? There has to be a 1 here that you can't see, okay? Those things have to be present. You must have a parenthesis squared. You must have a linear expression in here, and there must be a 1 here in front of the x, okay? But here's what's so easy. Whenever it's written in standard form, you know the vertex just like this. Are you ready? Take some really good notes. The number inside the parentheses, always change the sign. If it's positive, put a negative. If it's negative, put a positive. And the constant term on the outside, never change the sign of that. And there's the vertex just like that. That is so easy. So now I'm going to go ahead and quickly make a table of values. Right in the middle, I'm going to put negative 4, negative 3. Alright, well, going up would be a negative 3, negative 2. Going down would be a negative 5 and a negative 6. Okay, put a negative 2 in right here. Okay, students, here we go. Put a negative 2 right here. A negative 2 and 4 would be 2. 2 times 2 is 4, times 3 is 12, 12 minus 3 is 9, okay? Let's go ahead and put negative 6 in and see if we get 9 also. Okay, put negative 6 in, negative 6 plus 4 is a negative 2. Negative 2 squared is 4. 4 times 3 is 12, 12 minus 3 is 9. So yes, we get the same answer. Alright, let's try a negative 3. Negative 3 plus 4 is 1. 1 squared is 1. Times 3 is 3. Minus 3 is 0. Alright, let's put negative 5 in. Negative 5 plus 4 is a negative 1. When you square a negative 1, you get a positive 1. Positive 1 times 3 is 3. 3 minus 3 is 0. So guys, I hope this has been a pretty good review, helping you remember how to graph these polynomial functions, okay? It's really, really important you know all of this, alright? Okay, here we go. Now, let's finish up the video today by writing a quadratic function. In other words, I'm going to give you information, and you're going to write a quadratic function, alright? So here it is. Write the standard form of the equation of the parabola whose vertex is 1, 2, and passes through the point 1, negative 2. Now we need to stop right now and learn to write the model of the standard form of a quadratic equation, okay? So here it is. There we go. That is the standard form model of a quadratic equation. Y equals a parentheses exponent h quantity squared plus k. You need to know this. Now, of course, h and k are the vertex, remember? The vertex of this quadratic function here would be h, comma, k. Alright? Remember, this number here and this number here give you the vertex, just like back here. This number here and this number here gave you the vertex. Changed the sign of the 4, made it negative, left the negative 3 alone. Negative 4, negative 3. Alright? So, it's important that you understand this model, because we're going to use this model now to help us write the quadratic function. Alright? So here we go. We know, students, that the vertex is 1, 2. So let's think about that for a model here, okay? I've got an A here, X. Now, I just told you back here earlier, always change the sign of this number. And so think about it. Let's go backwards. If I've got a negative 4 here in my vertex, then I want a positive 4 here. These two numbers here will always have opposite signs. Okay? So my vertex is a positive 1, so I'm going to put a negative 1. Then don't forget quantity squared, okay? Now, don't forget that this number right here, this constant term at the end, is always going to be your y value. So whatever you have here, you're going to have here, okay? Alright, so, the vertex is 1, comma 2. So I know I have a 1 here for the h. So over here I'm going to put plus k. I'm going to put plus 2. Okay? So what I did there, students, is I took the vertex and I plugged it into the standard form of the equation of a parabola. Pretty simple. Okay? Just about 2 or 3 minutes ago I showed you guys whenever an equation is written in standard form, this number here, change the sign that goes here, and this number goes here. You don't change the sign. So that's what we just did. Okay, now I have a problem. This is cool. This is so cool. My graph is good. I'm done. I can circle it and say I'm finished, except there might be a number in front of the parentheses. So we have to test or check and see if there's a number in front of the parentheses. How do you do that, Mr. Hartwell? This ordered pair here was the vertex, and we used that to get some numbers here. Okay? Now, I know that the graph passes through another point. So if I can take these values and put them in for x and y, hey students, then I can solve for a and see what a is. So this is my x and this is my y. So where the y is, I'm going to put negative 2. Where the x is, I'm going to put 1. And here we go. First of all, 1 minus 1 is 0. And so that's going to give you 0 squared. Okay, students, I can see now somehow I believe I copied this wrong out of the book, because it's impossible to get 0 here for this. because then 0 squared is 0, and 0 times a is 0, and this whole term, if a is 0, think about it, if a is 0, then this whole term here is gone, because 0 times this parentheses squared is going to give you 0, and the reason it's impossible, well, Mr. Earhart, you don't know what you're doing. Did you get confused? No, not at all. I can explain to you why it doesn't work. In fact, it's actually common sense. If this is your vertex, guys, which I'm claiming it is, and 1 gives you out 2, there's no way 1 can give you out another value, okay? Because think about it. If your vertex is 1, 2, and it's right here, either the parabola opens up or it opens down, but there's no way that 1 will give you another y value out. It's impossible. So I think I must have copied this incorrectly out of the book. So let's improvise. Let's just make this a -1, okay? Alright, I apologize, and let's continue on. So all of the steps I've given you have been correct so far, and nothing is going to change except now we're going to use these two numbers. So where the y is, I'm going to put a -2. Where the a is, I'll leave it a. Where the x is, I'll put a -1, and then -1, quantity squared, plus 2. So next I'm going to have -1, -1 is -2. So we have -2 squared plus 2. Okay, next we're going to square this and multiply it times a. Are you ready? -2 times -2 is 4, and 4 times a is 4a. Wow, this is pretty simple, guys. This is algebra 1. Now bring this we're solving for a now. We want to see what a equals. So bring this +2 over and make it a -2. So now we have -4. -4 equals 4a. Now divide both sides by 4, and you're going to see that -1 equals a. -1 equals a. So see this equation right here. This is the right answer, except we've got to get rid of this a right here, okay? And where the a is, we're going to have to put what? A equals -1. So we've got to squeeze a -1 in there. Now, students, if you just want to put a negative sign and not put the 1 there, that's totally acceptable, okay? Or you can put the 1. That's up to you, okay? Pretty short lesson today. What's it supposed to be? A lot of this, or all of it, hopefully, is review. If you have any questions, don't hesitate to call